Hello everyone, I'm Preethi. I work at Intel as AI Solutions Manager. Today in this lightning talk, I'm going to basically cover one of the largest initiatives that the Linux Foundation has taken to be able to enable enterprises to easily deploy AI workloads called OPEA, which is Open Platform for Enterprise AI. This is just a short agenda. So we'll just cover briefly what is OPEA, what it has to offer, what that project overall basically covers, followed by how industries are actually starting to adopt and build solutions on top of this open source project called OPEA. Before we get started about what is OPEA, all of that, I just want to quickly flash a very sort of common problem we have in the AI market today. I mean, there are a lot of tools, a lot of models, a lot of service providers who offer AI for enterprises. It is very rapidly growing at a fast pace. But one of the biggest challenges is how does enterprise adopt this? They're still sort of, there's a very small portion which is showing real impact, but a large portion of the market, especially from the enterprise standpoint, is struggling to take this, from experimentation, proof of concept, and building like an entire, LLM end-to-end workload directly into production and sort of show a real business impact. So that's sort of, if you are using or trying to use AI in your enterprise workloads, it always gets very exciting to get started with, but when it comes to real production deployment, there are a lot of concerns that gets raised. And based on the Gartner report that was released last year is that it basically ran a survey with about 100 plus industry leaders to answer questions on what are the top barriers for adoption. And as you can see, the first top, sort of in this bar plot is the technical implementation itself, right? It's really fun to start off experimenting, but how do we actually get this to deployment? There are a lot of, gaps in the entire workload, and they need to fill the technical gaps to be able to bring this to production. Okay, and then of course the next biggest challenge or the barrier is the cost for running, right? So these two are some of the big gaps. In addition to that, there's also the talent gap and all of that. So in order to sort of minimize this gap, the overall AI ecosystem is working towards, bringing this into production really faster. And one of the ways to do that is through open source ecosystem, right? So now again, even within this ecosystem, there is a lot of complexity, right? So let's just take an example here, which is just really simple. We're not even getting into building agents, but at a very minimum, I want to go and deploy a chat assistant. Right, which is RAG based. So we need to first prepare data. So there has to be a team that has to do the data curation, involving vector DBs like Redis and Pinecone and all of that. Then there is a storage ISV part that also comes into picture. And there are application ISVs as well that basically has to sort of build tools to parse your data, create embeddings and all of that. So that in itself is a very exhaustive task. Okay. To be able to even start building an LLM end-to-end use case. The second part is actually the big monster, right? The build LLMs in itself. There are a lot of open source and even proprietary models that all the model providers provide. And then there has to be an aggregator that needs to come into picture, like Hugging Face and others who provide actually APIs to connect to these model endpoints. And more importantly, the underlying frameworks itself that needs to be optimized to run on your hardware really fast. So again, building LLMs, using it, fine-tuning it, or maybe just doing prompt engineering, all of that in itself is its own ocean, very vertically focused in your use case. And finally, now the fun part is the data and building LLMs. The final piece is actually deploying this in production, right? So there are a lot of SIs and OEMs and CSPs that come into picture here. Again, for an enterprise to decide, okay, what is my optimal infrastructure that I need to have? what is the cost that I need to keep in mind to actually bring this into production. So just imagine an enterprise that has to go through all of this without having to, with open source components, without having to rely on, proprietary model service providers and all of that, right? So it's a big hassle to, connect this end to end. Right, so these are some issues that I just wanted to, I know most of you know, but just wanted to level set before I go into what exactly is OPEA. This is just a deep dive into the same architectural diagram, right? So very basic. The left-hand side basically has all the embeddings, data ingestion, retrieval, re-rankers, and everything. And after that, there is LLM inference, prompt using guardrails for prompts. After that, also using guardrails, and then finally, again putting a re-ranker on top of that. So this is sort of an architectural diagram. This is a piece that I just want to sort of flashlight into, because this is the most, I wouldn't say, the complexity is always, is anyway around this piece, but just deploying an LLM model at scale, that is production grade in itself, is again challenging. So let's just keep this in mind. So what an enterprise basically needs is, again, I want this architecture, I want to deploy this at production scale. Now I want it to scale. I wanted to do dynamic scaling. I wanted to do horizontal pod scaling, all of that, right? And then definitely security and reliable models, all of that. And of course, enterprise want to achieve this at an optimal cost. Now, having said that, what exactly is OPEA? So what I just showed, making it easier, is actually the goal of OPEA, is to basically enable developers to deploy production-grade GenAI solutions that has all of these different factors that I just mentioned, and they can get to production really fast. So OPEA is basically a project that Linux Foundation launched last year. So it's basically a framework that offers composable microservices that you can use as building blocks across different pieces for you to build an end-to-end LLM-based solution that can be, data stores and prompt engines, everything, without even you having to know, to deal the complexities of the, components itself that could probably come from, Llama index or Haystack or whatnot, right? So offering this as microservice where you deploy and, talk to each of these different microservices just through HTTPS and endpoints just makes it very easy for you to build a very composable and maintainable, end-to-end LLM workload. So basically, it's a framework that has composable microservices. Followed by that, now we have these microservices as building blocks for each of these different parts. OPEA also provides an architectural blueprint for you to go and build an agent Q&A use case or a chat Q&A use case. Gives you a template for you to go and deploy this as a mega service and all the other components that's actually needed outside of this microservice. So it provides you blueprints for each of these different use cases, whether single node or on a multi-node that you can deploy in help charts. All of those blueprints are available as part of OPEA. Now you have these microservices and mega services. You can also, the next part is you can basically slice and dice and also use it for your other more custom-made Q&A or assistant type applications. Finally, there is also a part that basically also helps you assess how your workload is, how accurate your model is, how accurate your entire end-to-end workload with RAG is, how qualitative my model performance. Again, OPEA overall is hardware agnostic. So you can basically take these blueprints, deploy it on NVIDIA or Intel or AMD processors, because again, it's a project that is driven solely by Linux Foundation, and there are about 50 plus partners who are actually contributing to this, where users don't even have to know what kind of framework they're using. They're ultimately going to be building a blueprint and deploying that at production scale just by using microservices. This is just an in-depth, software architecture in itself for OPEA. So if you see these individual components in itself are microservices. are microservices, and on top of this, you have the mega service. There's a Gen AI Studio, which is basically, drag and drop, build your own blueprints and deploy them. There is a very common ecosystem pipeline builder, whether you use Hugging Face or LangChain, whatnot. So there is a very standardized pipeline builder, and of course, endpoints, right? Everything, once when you deploy, you'll just access them as endpoints. And on top of that are actually the use cases, which are the blueprints that essentially uses a combination of all of this. On the right side is just an elaboration of this that basically shows, okay, when I deploy, each of these different pieces are essentially microservices, and then there is a mega service, all of these calling different serving engines, whether you're deploying it with VLLM, TEI, all of that. So all of these this is a chat Q&A blueprint. Similarly, there are several other blueprints. Again, you can probably remove this microservice. So instead of going and having to remove a code base, you're just removing a microservice. So this is where we are sort of making it easy for users to basically start building production grade software. Again, here is just a slide that I just want to show what is below OPEA, what are the components, who are the partners we are working with. So the basic PyTorch, TensorFlow, all of that, and then there are all these different serving engines, VLLM, Triton, TorchServe, Optimum, Habana, all of that, which is basically widely available across multiple hardware vendors. On top of that are again the application frameworks itself that are being widely adopted to build pipelines, like the LangChain, Haystack, and whatnot, and then on top of that is basically OPEA. This basically just shows what is available in OPEA today. I mean, since given this is a very short talk, I just want to highlight the main thing we have here that we deployed last year in 2024 is making it available to deploy at scale with Helm charts and horizontal pod scaling. And for 2025, OPEA's plan to have something that is very similar to NIMS called OPEA Inference Microservices. And there will be agents that is coming up very similar to the blueprints as the examples. And we will continue to seamlessly integrate across multiple application frameworks like LangChain, etc., and making it available as sort of templates that is available to CSPs. Here are just a list of partners. There are about 50 plus partners who are actually actively contributing to this project. There are two initiatives. One is contributing to OPEA. The other part is enterprises starting to adopt OPEA as well. Just some sub-projects. Components has all the different microservices, individual pieces that you can stitch together to come up with a mega service to put together blueprints, or also called as examples. Infra basically has another project that uses Terraforms for you to deploy in multiple CSPs. Evaluation is basically doing a bunch of benchmarking. Now, one of the things that I want to highlight here is this enterprise inference as to how industries can actually start picking up OPEA and start building enterprise-grade solutions. Now, there are two ways that you can do. You can take these blueprints and start building enterprise-level workloads to deploy. And the other part is, okay, I'm taking OPEA, I'm taking multiple components, and I'm starting to build my own set of solution on top of that. One of the things is enterprise inference, which is going to be the second part of the discussion. So you pick up OPEA blueprints and the microservices and all the containers that are offered as part of this effort, and start putting together your solution that's more in-depth for a specific service. So such as building enterprise RAG or enterprise inference, or maybe enterprise level guardrails, right? So here in this case, I just want to show one of the solutions that we've come up with, which is open source. Again, it's available as part of OPEA sub-project itself, called Intel AI for Enterprise Inference. So if you see, OPEA in itself has different microservices and Helm charts for you to deploy at scale. But in order for us to go one step above, there are other core components that are needed, better orchestration layers with better Kubernetes support. And on top of that, inferencing engine and authentication, providing gateways and others, monitoring services, all of that. So all of these are essentially packaged as a one-click installer software that users can basically go and deploy this enterprise software, one click, and then they get all of these different layers installed with models that are supported. So today it supports more than 20 different models, all the llamas, Gwen models, mixed models, all of that, up to Llama 4 even today. So you basically pick this up, you just deploy, and your LLM, all of your LLMs that you need for your enterprise are readily available on a Kubernetes-based environment that can optimally run on your hardware. So here in our first round, we have started doing that for Intel Xeon and Intel Gaudi processors. So you don't have to worry about managing or deploying, setting this up from scratch. So all of this is just a one-click software that deploys. One aspect is deploying it, and the other aspect is basically communicating it through OpenAI compatible API. So let's just say you have a use case that you have written basically, using GPT-4 or Claude, and you don't want to be paying, you want to have it in-house. This is one of the initiatives where you can basically deploy the endpoints and communicate through the same APIs. Only thing that is needed is you just change the model endpoints. Right? So you use OPEA, and at the next level, you're adding more functionalities to it, taking the same capabilities and interacting it through OpenAI compatible APIs. Okay, so just quick architectural diagram. One thing is, like I said, very easy integration here. So if you already have a workload that's probably running on NVIDIA and it's costing high, something like Bedrock services that you're using, you want to do it in-house. You basically pick this, install install it, and then you get access to all of these different models that are actually running across multiple pods, enabled with all the ingress controller for load balancing, authentication service, and everything. You can host it, all of this in-house. That's optimized for your hardware. Again, the previous flowchart that I just flashed, I just want to show. So this is the part. So entire thing is OPEA, but this is the part that is actually an enhanced version of OPEA, where you deploy endpoints, you interact with these endpoints, and then you just go and switch your wherever you have deployed these endpoints. Just change the URL, talk to Llama models. Change your URL, talk to Mistral models. So those kinds of capabilities you get with this enterprise inference. Just want to quickly show how we are sort of starting to distribute this, just for ease of use, right? I understand, again, going and deploying this on-prem, if that is a big headache. So we are actually working with some of the top CSPs, for example, Denver DataWorks. All of this is already readily available as serverless deployment, all the models and everything at a much lower cost. So they basically have this enterprise inference deployed on Denver DataWorks, on Xeon and Gaudi process, so you can just basically go and interact with these model endpoints. So if you already have an enterprise workload running with LLM, and you want to go try multiple models, maybe try a different kind of hardware, so you can just go sign up for some kind of beta that they have today, and then get those model endpoints, plug it into your workload, and see how fast it runs. So it supports, I think, about 128K context length today. So this is actively running. So one way is you basically deploy. The other way is you can just go talk to these CSP providers to get it. So another effort is with IBM. So they have something called as deployable architecture, which is again a blueprint just for enterprise inference. Just run this, deploy it, and it runs on IBM. All of these models readily deployed as endpoints. Go and connect these endpoints to your workload. So with that, I just wanted to finish my short lightning talk with some call to action. So if you are interested in contributing to the full open source OPEA, so here is the barcode that can take you to how to get started with. There is a getting started guide, lots of tutorials and everything available. So if you want to access the endpoints that I just mentioned working with Denver, here is a link, so denverdata.com/intel. So you can basically go sign up and access these endpoints in Gaudi, which is much more cost effective. Again, some white papers that is released on IBM Cloud for you to better understand how sort of competitive it is basically to run this enterprise inference on a better hardware with a better TCO. And if you need any more information, you can reach out to us at inference@intel.com for more information on how to contribute to OPEA and other resources. All right, that's about it. Thank you.